Hi, in this video I'm going to show you vector related lambda and how that vector related lambda can help you to solve Excel BI challenge. So we are going to solve this challenge using our vector related lambda. So let's get started with this vector related lambda first. So I have vector 1 and vector 2 and I want to do a left join. So what this means is I want to find only those item that is present in the vector 1 but not in the vector 2. So when I'm saying vector, that means it's a one row or one column of data array. Okay, so it could be on the row or it could be on the column, but mostly it's a one column or on row. So in the vector 1 and vector 2, so I want to find only those items that are present in this vector 1. So let's see, how can I do this? Let's see which items are present in vector 1 as well as in vector 2. Let's see, match, and lookup value is going to be this one, and my lookup array, I'm looking into this vector 2, right? And I'm going to do exact match. Now you can see it says NA because snowflakes is not present on the vector 2, but danced is present, so that's why it's returning the index, right? And this one, the and the air is also present in this vector 2. So what I need to do, to the left join, I want to find only those items that are present on vector 1, not in the vector 2, right? So what I can do, I can just say, okay, if it's a number, that means it's present on the vector 2 as well. So if it's not a number, then those are my valid output actually. So what you can do, I can just say not is number. So if it's not a number, now I can say it's a true. So snowflakes is not present on the vector 2 but present on the first one. So what I can do, I can just add one more filter and filter this one, and this is my criteria. Now you can say it says snowflakes and in, that is only present on the vector 1 but not on the vector 2. Now I can create a lambda out of this and that will work well, right? Like I can just say lambda vector 1 and vector 2, and this is my vector 1, this is my vector 1, this is my vector 2. Now close this lambda and provide this, and as you can see, it's returning the same result. I can set this lambda using vector.left join. Now what about the right join? So it's the opposite. So I want to find only those items that is present on the vector 2. So same idea. So let me just take this filter part, right? Actually, let me just copy the whole thing. So this is going to be, I need to filter vector 2. I need to search vector 2 in vector 1. That's it, nothing else. And you can see leaves on trees rustled as wind through. These are items that is present on the vector 2 only, but not on the vector 1. Now vector.union, so that is basically all the distinct item between those two vectors. So like I want to take this as well as I want to take this, and also I want to take the item that is present in both but only once. So what can I do? I can just v-stack this, okay, this one and this one. That will give me the stacked item list. Now I can just say unique and return unique columns, skip that, return every distinct item, right? False, or you can just skip this because false is the default option, right? So that's my vector.union, right? Now one thing that I want to explain, that let's say I have this vector 1 is in columns but vector 2 is in a row like this. In that case, this will cause a little bit problem because when we do the v-stack, it will be a 2D array, right? So in that case, I think you should just wrap this up with a 2 col, and this one is a 2 col as well. So it will be a column vector, okay? So that's the vector.union. Whatever the intersection. So intersection is that those items that is present in both vector only, okay? So in this case, I think it's the and air. Those are present on this vector 1 and vector 2 as well. You can see the air, right? So what I can do, we can use the left join idea in vector.intersection. So what is this do is, like, you know, in this section it just say, okay, I want to find only those items that is present on the vector 1, right? So if I just get rid of this not operator, right, what it will do, it will just give me the item that is present on the vector 1 as well as in the vector 2. And let's look at this. You can see the danced, so that is this danced, and the air. So those are the three words that is present in both vector 1 and vector 2. So that is the intersection. Now what is this anti-intersection is, like, it will just give me those items that is only present in vector 1 and vector 2, but it will remove those items that is present in both vector, right? It's like just remove this item and just give me all the item between these two and just remove this, right? So that is going to be the intersection, and in that one we can use this unique idea. Let me show you. So let's see, unique. Now if you look into this unique, it says return items that appears exactly once, right? So if a specific item is present in both vector, then it will be present twice, right? And when I want to see the only once, then it should be only present in either vector 1 or vector 2, right? So I can just say return items that appear exactly once, true, and look at this. So these are the anti-intersection, right? Now let me just convert this into a lambda vector c3 and this, and you can see snowflakes in leaves and so on. Now I'm just going to copy this lambda and I'm going to use that in this problem. So I'm going to use Excel lab here, relate anti-intersection, and this is my lambda for that one. Now I'm going to get the data, so sentence, and that is in 8. So result going to be by row sentences. For each row it will give me sentence 1 and sentence 2. So lambda row data, and let me get another let statement, words 1, and that is going to be text is split, and text is index row data and just a space, and for words 2 it will be like this, column 2. Now this is going to be my count, right? So anti-intersection, so words 1, words 2, and I just need to count, right? So rows and result, and let's see what it does. That's it. You can see 9, 7, 11, 7, 7, 11, 8 and 10, and that's it. And that's how we can use our reusable lambdas. You can set these lambdas in your collection and you can use this every time you want. Now one more tips on this one is that I could use some simpler way that I have seen other user to use, that is string concatenation, and that's a valid way for this particular problem, but I prefer this vector anti-intersection way because it's not sometimes only that I need to find based on the space or some other criteria. I could do this on some sentences instead of just words, right? So that's why I like this idea. That's it for this video. Let me know if you have a different approach for this particular problem or for this particular vector related lambdas, and I'll consider that in my next video. Have a good day. Thank you.